Okay, YouTube, in this video we're going to continue to look at subtracting in this case, but also adding fractions and rational expressions, having unlike denominators. And in this video we're actually going to focus on just one of our methods for doing that, and that is to use the least common multiple. So in terms of what we do here, we're both going to do and write out the steps for doing this. So in terms of adding or subtracting fractions, we see that we have a couple of rational expressions here. The very first thing I want to do is factor the denominators completely. So factoring the denominators completely, what that's going to allow us to do is to find our least common multiple. So factoring these completely, if you haven't started already, let's go ahead and take a look at these. It looks like over here in the left denominator, they share a common factor of 2. So we get 2 times x minus 1. And what we're doing is we're subtracting this negative 2x minus 1 over now. When we factor this, it looks like it would have to be an x minus 3, x minus 1. Those would be the factors here. So in terms of factoring completely, we've already factored these. The next step is going to be to determine the least common multiple. And so our least common multiple here, let's go ahead and do this. We're going to list it. And the way this works is we're going to include on our list of least common multiple factors any factor that it shows up at its highest power. So that is to say, when you look at both of these denominators, they have factors. In the first denominator, we have a 2 and an x minus 1. In the second denominator, we have an x minus 3 and an x minus 1. So starting with our 2 here, we see that the highest power of 2 we see in either denominator here is a 2 to the first. So we have 2 to the first. Now x minus 1, it's being raised to the first, but it also is being raised to the first over here. So we would say the highest power of x minus 1 is 1. And then looking over here, we have an x minus 3 to the first, and we have an x minus 3 to the 0 over here. In other words, we don't have any. We say that x minus 3 to the first is the highest power of x that we see happen on any of these. So to write this a little bit more cleanly, and we leave this factored, do not unfactor this, we get this is our LCM, and I'm going to put a box around this. So the way this works now is this. I suppose we are going to multiply each fraction. Each fraction's num and denom by the factors in the LCM that it is currently missing. In the denominator. So the way this works is that as we look at this, we say, well, I really want my common denominator to be 2 times x minus 1 times x minus 3. What we have here is a situation where x plus 2 is currently over 2x minus 1. And we have this being subtracting this negative 2x minus 1 over x minus 3, x minus 1. So the way this works is we want our denominators to look like this. So what I've written over here is basically we're going to take each fraction and multiply the top and the bottom times any of these factors in our LCM list that it doesn't currently have. So for instance here, I notice that we already have the 2 and the x minus 1 to the 1. What I'm missing over here is an x minus 3. So I'm going to take the top and the bottom times an x minus 3, essentially taking it times 1, since x minus 3 over x minus 3 is equal to 1, and 1 times anything is itself. So over here on the right expression, we're going to take this now on top and bottom times anything it's missing. And it looks like that on our LCM list, it's already got the x minus 1, x minus 3. What it needs is a 2. So we're going to take the top and the bottom times 2. Excuse me. So now, I suppose we're going to write as a single ratio over the LCM. And so what we get here is the LCM, which is clearly this thing on our list here, is 2x minus 1, x minus 3 here. This is our LCM, but what we get on top over here on the left is x minus 3 times x plus 2. In other words, everything in this numerator times this x minus 3, and then we say minus, I'm getting this minus from right here, negative 2x minus 1 times 2. So the way this works is as we write this as a single ratio, I suppose I would say that we would simplify the numerator. The neat thing about it is because we use the LCM, once we simplify the numerator, we're not going to be able to do any more reducing. So what I mean by simplify the numerator is we're going to go ahead and distribute or FOIL, whichever one applies here. So we get this. We get x times x is x squared. X times 2 is 2x. Negative 3 times x is negative 3x, and negative 3 times the 2 is negative 6. So everything there minus, now I'm going to distribute my positive 2 throughout here, so we get negative 4x minus 2. We're subtracting all of that off, and this is still all over our LCM, 2x minus 1x minus 3. So to simplify this, we're going to go ahead and add the opposite. So I'll distribute this negative through, making that negative 4x a positive 4x, and making this negative 2 a positive 2. All we're going to do is just go ahead and simplify the top here. So in terms of x's squared, I have 1x squared right here. X's, we have 2x minus 3x is negative 1x. Negative 1x plus 4 more x's is 3x's, so we get 3x's there. Oops. 3x's. And then we get a negative 6 and a positive 2 is a negative 4. So this right here is all over 2x minus 1, x minus 3. And just to show you here, if you tried to factor the top, we say 2 factors of a negative 4 that add up to be a positive 3 there. Let's go ahead and take a look at it. If we do factor this, would it simplify? And so in this case, we get x minus 1, x minus 3 here. Looks like we would get maybe an x plus a 4 and an x minus a 1. So this does indeed factor here, and what we notice is that we lose this common factor of an x minus 1. So our simplified final expression here is x plus 4 over 2x minus 3. So simplify the numerator, factor, cancel common factors. But this would be our simplified form right here. So one thing that we want to make sure we do before we're done is this. With our LCM being 2 times x minus 1, x minus 3, we want to make sure that we restrict the domain to not include positive 1 or positive 3. Cheers.